Nintendo Switch. I'll show you what's going on. It's a beauty. It's a beauty. Isn't that pretty? The likelihood that we're going to have secondary issues is, I would say, is pretty high, but you just never know. But that's a whole lot of pins that are touching. Anyway, so our method for dealing with this situation will be to disassemble entirely, remove the port, do our testing, because at this point there's no point in doing any testing with this on the board. Those pins are going to skew all of the testing that we could possibly do. So we will disassemble, we'll remove the board entirely, we'll remove the port, and then we will test for any secondary problems. Okay, we have the board out of the housing and we are set up to remove the port. That is what we have to do before we can do anything else on this job. So we will do what we normally do. Well, first thing we'll do is we'll throw up the temps while I get my equipment on. Fume extractor and all that fun. Alright, get you focused in. We will do what we always do. We will flood with low melt. And then we will bring the sauce, blow that port right off, and go from there. Looks like a good pull to me. No pull pads. Once again. Alright, let's check for any bridged connectors. Any bridge pads. And it looks like they're all clear. And ready for testing. We will connect our meter on the right settings. In this case, we want to be in continuity mode. We will get centered in on this M92T36. We'll switch you to microscope so you can follow along. First capacitor we want to check is this one right here, which is tied to the Pi 3 USP on the other side of the board. Okay, one side is ground, one side is not. This one is not. Appears to be good. Now, if you follow this one, it has a signal line going through the M92T36. So that's really the side you don't want to be shorted to ground on this one, because it has only one. Alright, so again, we want to follow that line to this capacitor. And that's the side we don't want to be shorted on this one. And we follow that process all the way through. We don't want that to be shorted. We don't want that to be shorted. We don't want that to be shorted. We don't want this one to be shorted. Now this one has two, so one side of a capacitor is always going to be on ground. So if this has two signal lines, one side is going to be ground. That's our ground. That one is not. Alright, let's check our CPU one and then follow along. Okay, we don't want that one to be shorted, and it's not shorted. Very good. Now we're going to pop up over here to the MOSFETs, and we're going to check the MOSFETs. Everything looks good there. We're going to check our little filter, and we're going to take note that this does have the ESD diode arrays. They can sometimes be problematic, but... Alright, let's check our little fuse. The invincible fuse, as I like to call it. It's very much like a MacBook fuse. Alright, now we're going to check our test pads. This one should be ground. Alright, it's fine. None of these here in the middle should be grounded at all. Alright, everything looks good. Now we're going to check around the BQ 24193, the test pads there. Everything looks good. Now one side of this one should be ground, this one, and this one should not be. Very good. I'm going to flip the board, and we're going to take a look at our Pi 3 USB section, and make sure everything is copacetic here. Make sure you're in view so you can follow along. Alright, so we want to test all these filters. They need to have continuity straight through, but not side to side. Man, these guys may have gotten really lucky. Alright, we're going to check the signal side of the Pi 3 USB capacitor, this big one right here. I know a lot of people will go through and check all these guys, but I have not found that they show me anything. This one right here is your primary target for testing. And on this side of the Pi 3 USB, where when it goes to the chip itself, you do not want it to be shorted. And it is not shorted. Very good. That side is ground. Alright, so it looks like, at this moment, it looks like they've gotten very lucky with that super smashed up port, that there has been no collateral damage. Now, we can't know that 100% without testing, and in order to do that, we must put on a new port. I mean, we could do some testing with the battery without the port, but at this point, I'm pretty confident that we're going to have no collateral issues based on the testing. So I'm going to go ahead and put on a new port, and then we'll do our testing. So we will clean up, wake everything off, and go from there. And actually, I did forget to test an area, so let's do that real quick. I forgot to test everything around the BQ24193. We just kind of skipped over that. Okay, we're going to test our filter. We want continuity through that filter. And we're going to test the signal side. Same thing. They may be bigger traces, but it's still the same deal. If it's going to the BQ24193 and it's only one side, you don't want that to be shorted. Now this one's got two sides, so one is going to be ground. This one's going to have two sides, so one's going to be ground. Alright, so again, everything checks out. Oh, I'm sorry, jeez. So, we'll do it one more time here because I was completely out of screen. Continuity through the filter. Signal side on all the caps. This one has two. So one side's going to be ground. All the ones with one, you don't want shorted. This one's going to be ground because this one has two. Alright, everything checks out there. Alright, get back to my cleaning up here. Okay, we're ready to perform a little test. See if we're getting behavior that we expect. Take a look at channel 1 down on the bottom left. Let's follow along. Okay, it looks relatively normal. And that looks relatively normal. Very good. We can perform a test with the battery squid as well. Just to double check, but I don't expect there's going to be a problem. But we have it here, so why not? We built the squid. So why don't we just use it? For this, we'll activate with the OEM. And this will be on channel 2, if you want to follow along. And that all looks relatively normal to me. Very good. It is booting. Alright, so next issue is I need to finish cleaning up off screen, and then we will put it back in the housing, enough to test, and go from there. Okay, we're prepared enough to do another test here, or we're assembled enough to do another test here. I'm going to be testing with my known good battery. Of course, we have to have the power on for that to work. Okay. Full battery symbol. And boot up. Okay. I actually have the speakers connected now. Okay, let's switch it to the other side, make sure we're charging on both sides. And we are fast charging on both sides. Excellent. Alright, so we'll power down, we'll fully reassemble, and let it charge on its own battery for a while, and then we'll perform some more in-depth tests. Okay, we're back up and running on our battery. We are up to about 20% charge. We're going to test their Joy-Cons real quick. Make sure everything is hooking up and behaving normally. Alright. It is charging their Joy-Cons. Make sure we're picking up our networks. We are picking up our networks. All good. Back home. Let's put their game back in. Make sure it is reading fine without error. And it is. There you go. Okay. So next thing we'll do is we'll set up for dock test, and we'll be back for that. Okay. Okay, as you can see, we are docking. So we are charging both sides, we're docking. The clients got really lucky because there was no collateral damage. That's good news. Okay, in summary, we had a really badly smashed up port with a whole row of bent up pins, but luckily it looks like nobody put power to it once it was already smashed up. There was no collateral damage, so it just turned out to be a simple port exchange. So that's really it for this repair. If you have any questions about the equipment I used, take a look in the description below. It's all linked down there. Do me a favor, if you got any value out of this video, hit the like button on your way out. And if you want to see more videos like it, hit the subscribe button, maybe the notification bell, and you'll know when I post videos, usually about twice a week. If you want to do a favor for the whole community, and I'm talking about the repair community, like specifically the console repair community, Jason's Electronic Repair, the Coder, Joey Does Tech, Wayne's New Repair. If you're learning something from it and you're actually able to repair something, share your story. Share it on Facebook or Instagram or Reddit or wherever you like to post. You know, it would really help the channel, and it would really help everybody grow and share it and get the information out to more people, and we'd all really appreciate it. I'm kind of speaking on behalf of those other guys. I didn't really check with them when I said that, so, but that's just my request on their behalf and mine. If you're able to repair something and because of something we showed you, tell the story. Just share the story. That's all we're asking. All I'm asking anyway. Anyway, that's all I really had to ask of you. I really appreciate the channel support, and we'll see you in the next video.